Hello everyone, my name is RIVEST and I'll be presenting on symmetric key crypto system. What is symmetric key cryptography? So symmetric key cryptography is a type of encryption in which the same key is used both to encrypt and decrypt messages. It was a method designed to facilitate security communication between governments and militaries. Nowadays, symmetric key cryptography are used in various types of computer systems to enhance data security. So how does symmetric key works? Symmetric encryption relies on a single key that is shared between two users. The same key is used to encrypt and decrypt the plaintext or message. The process of encryption consists of running a plaintext, which would be the input, through an encryption algorithm called a cipher, which in turn generates ciphertext, which would be the output for the encrypted message. If the encryption is strong enough, the only way for a person to read or access the information contained in the ciphertext is by using the corresponding key to decrypt it. The process of decryption is basically converting the ciphertext back to plaintext. So here we have some of the advantages and disadvantages of symmetric key cryptography. So one of the advantages is that it is extremely secure. When used, symmetric key encryption can be extremely secure because of its extraction process. Another is that it is relatively fast. Encrypting and decrypting symmetric key data is relatively easy to do, giving you good reading and writing performance. Two disadvantages: sharing the key. This is a problem because you need to have a secure way to get the key to the receiver. And the other, if the key is compromised, there could be serious damage because both encryption and decryption are compromised. Here we have some of the types of symmetric keys, which are DES, triple DES, AES, the IDEA cipher, and RC5. So we'll start with DES. DES simply means Data Encryption Standard. It was designed by IBM researchers in 1970 and was adopted by the US government as an official Federal Information Process Standard in 1977 for the purpose of encryption of commercial and sensitive yet unclassified government data. It was the first encryption algorithm proved by the US government for public disclosure, which ensured that DES was quickly adopted by industries where there was need for strong encryption. DES began to be used in a wide variety of embedded systems such as smart cards, SIM cards, and network devices that required encryption like modems, set-top boxes, and routers. So how does DES work? DES is a block cipher, which simply means a cryptographic key and algorithm are applied to a block of data simultaneously rather than one bit at a time. DES groups the plaintext message into 64-bit blocks to encrypt it. The process involves 16 rounds and can run from 4 different modes: encrypting blocks individually or making each cipher block dependent on all the previous blocks. Decryption is simply the inverse of encryption, following the same steps but reversing the order in which the keys are applied. For any cipher, the most basic method of attack is brute force, which involves trying each key until you find the right one. The length of the key determines the number of possibilities, and hence the feasibility of this type of attack. DES uses 64-bit key, but 8 of those bits are used for party checks, effectively limiting the key to 56 bits. Hence, it would take a maximum of 2 to the power of 56 or 72 billion plus attempts to find the correct key. Although the number of attempts is really high, large numbers of computers cooperating over the internet could try all possible key combinations. Because of this vulnerability, the US government has stopped using DES since November 1998. So cipher block chaining is a mode of operation for DES. In case I did not mention what a block cipher is one in which a sequence of bits are encrypted as a single unit or block with a cipher key applied to the entire block. So cipher block chaining uses what is known as initialization vector for a certain length. One of its key characteristics is that it uses a chaining mechanism that causes the decryption of a block of ciphertext to depend on all the preceding ciphertext blocks. As a result, the entire validity of all preceding blocks is contained in the immediately previous ciphertext block. A single bit error in a ciphertext block affects the decryption of all subsequent blocks. Rearrangement of the order of the ciphertext blocks causes decryption to become corrupted. Basically, in cipher block chaining, each plaintext block is XORed with the immediate previous ciphertext block and then encrypted. What is XORed? XORed means exclusive OR, which is a Boolean logic operation that is widely used in cryptography as well as in generating parity bits for error checking and fault tolerance. XOR contains 2 input bits and generates 1 output bit. Electronic Code Book, or ECB. So this is another mode of DES operation with the characteristic that each block of plaintext has a defined ciphertext value and vice versa. So basically the same plaintext value will always result in the same ciphertext value. ECB is usually used when a volume of plaintext is separated into several blocks of data, each of which is then encrypted independently of other blocks. ECB has the ability to support a separate encryption key for each block type. ECB is not a good system to use with small block sizes and identical encryption modes. Why is because some words and phrases could be reused often and same repetitive part blocks of ciphertext can emerge, which could increase a codebook attack where the plaintext patterns are obvious. So as you would see in the little diagram there, you have the plain image, and when it undergoes a ECB encryption, you can see still somewhat how the image would still look. DES security. So basically DES cryptography has been compromised due to the increase in computing power. Through the use of the internet, a network of PCs can be used to crack DES. DES became vulnerable to attacks by an exhaustive research for the 56 key bit. Because of this, DES has been replaced by triple DES and by then Advanced Encryption Standards, AES. So what is triple DES? Simple as it is, triple DES is a type of cryptography where the block cipher algorithms are applied 3 times to each data block. In this method, triple DES key size is increased to ensure additional security through encryption capabilities. So basically what they did is just took DES and run that 3 times to increase security. So how does this work? Here we have an example where Alice is trying to send a message to Bob. So in the process, what would happen is, the first thing, the plaintext block would be encrypted using DES with key 1. It would then be decrypted using DES key 2, and finally encrypted with the use of DES key 3. The output of step 3 is the ciphertext, and when decrypting, it would just be the reverse of the encrypting process, where the ciphertext would undergo decryption by key 3, encryption by key 2, and then decryption by key 1. And then Bob would be able to see the message of Alice that was sent by Alice. Moving on to advanced encryption standards. So AES is another type of cryptography used to secure data. It is a block cipher that can encrypt and decrypt information. AES has an encryption key length of 128, 192, and 256 bits, which can encrypt and decrypt data in blocks of 180, 128 bits. AES encryption key length 256 is also known as military-grade encryption. This cryptography method can resist most, if not all, known attacks. So how does this work? Like other block ciphers, AES uses rounds of encryption that carry out cipher transformation. Each round typically consists of several building blocks designed jointly to create a function and then run multiple times. The number of rounds AES performs depends on the length of its key. So at 128 bits, it does 10 rounds. At 192 bits, it does 12, and at 256, it does 14. Each round consists of 4 layers, which are subbytes, shift rows, mixed columns, and add row. So subbytes provide excellent confusion. What is confusion? Is a property of a secure cipher operation. It makes a relationship between the ciphertext and the symmetric key as complex as possible. This creates non-linear tables, which are extremely good at eliminating patterns. Shift rows provide diffusion, where diffusion is another property of operation a secure AES cipher does. The goal here is to dissipate the statistical structure of the plaintext over the ciphertext by spreading every part of the input to every part of the output. Mixed columns provide further diffusion for added effectiveness. An add-round key mixes a key, making it impossible for an attacker to calculate what the cipher does. The RIINDAEL block cipher. So this algorithm was designed in relation with AES for the following purposes: to resistance against all known attackers, design simplicity in comparison with other algorithms under consideration, and code compactness and speed of a wide variety of platforms. The RIINDAEL cipher can be categorized as an iterated block cipher with a variable block length and key length that can be independently chosen as 128, 192, or 256 bits. So how does the RIINDAEL cipher works? Encryption under RIINDAEL is achieved through a series of matrix transformation. Each round uses a variable amount depending on the key or block size being used. As before, 10 rounds are usually used for key or block size 128 bits, 12 rounds for 192 bits, and 14 rounds for 256 bits. RIINDAEL is a substitution cipher which uses a combination of 3 uniform matrix transformations: the linear mixed transformation, the non-linear transformation, and the key addition transformation. Before the first transformation or round, a simple key addition layer is performed, which adds the overall security of the process. The TWOFISH algorithm is basically in the same category with the RIINDAEL algorithm. So the TWOFISH algorithm is a symmetric block cipher that uses a single key for encryption and decryption. TWOFISH has some distinctive features that set it apart from other cryptographic protocols. For one, it uses pre-computed key-dependent SBlocks, And S box stands for substitution box. This is any symmetric key algorithm which performs substitution. In TWOFISH block cipher, the S box works to obscure the relationship of the key to the ciphertext. TWOFISH uses a pre-computed key-dependent S box, which means that the S box is already provided, but is dependent on the cipher key to decrypt the information. Next, we have the International Data Encryption Algorithm cipher, or IDEA cipher. So this is a symmetric block cipher which takes 64 bits as an input, 28-bit key, and perform 8 identical rounds of encryption in which 6 different subkeys are used and 4 keys are used for output transformation. It applies both confusion and diffusion properties. Confusion, just to recap, confusion has to do with the relationship between the key and cipher, and diffusion has to do with the relationship between the message and the ciphertext. And the last cipher I'll be touching on is the RIVEST cipher 5. So RC5 is a block cipher of variable block length and encrypts data using integer addition, the application of a bitwise exclusive or and variable rotation. The key size and number of rounds are also variable. Block size for this cipher would include 32, 64, and 128 bits. The number of rounds can change from 0 to 255, and the key size can range from 0 to 2048 bits. And that would be the end of my presentation. I would like to thank everyone for viewing, and if there are any questions, please feel free to leave a comment